This is a presentation on word retrieval difficulty and Wernicke's aphasia. What is Wernicke's aphasia? It's a problem with words. Aphasia is the result of brain damage in the superior posterior left temporal lobe. With it comes severe deficits in language comprehension and expression, deficits in auditory comprehension, reading comprehension, spoken and written expression. The Wernicke's area is associated with the processing of spoken and written words. Some of the common speech and language behavior characteristics are severe comprehension deficits in spoken and written language. Handwriting is mechanically good, but it lacks content and meaning. Speech production is fluent and grammatically correct, but it also lacks content and meaning. Speech production is often referred to as empty speech or word salad. Word retrieval difficulties are also characteristic of Wernicke's aphasia, and paraphasia constitutes the major behavioral consequence of these word retrieval difficulties. Neologism and circumlocution may also be present. Before discussing word retrieval difficulties and the resulting paraphasias, the nature of word retrieval should be examined. Word retrieval, also known as word finding, is the ability to gain access to and retrieve a known and understood word. Word finding is the processes involved in mentally identifying and producing words needed to express a thought or name an object. Words have two very different storage systems in the brain, and successful word retrieval relies on both systems. The two systems are the meaning or semantic storage system and the sound or phonologic storage system. In the semantic storage system, words and their meanings are stored in the brain as connections among nerve cells. These connections correspond to what we call word associations, which are organized and correspond to neural connections in the brain. These neural connections can encompass large and distant areas of the brain. Each meaning connection represents one root to that word in the brain. The phonologic storage system is where sounds and their organization are stored. The brain must recognize that a given symbol, a phoneme or grapheme, represents a sound, and it must know how sounds go together to make a word. The phonologic system involves specific and concentrated nerve cell connections. This picture illustrates both of those storage systems. Word retrieval and production is believed to be a two-step process. Lexical knowledge is embedded in a network of three layers: a semantic, a word, and a phoneme layer. This figure illustrates a model of the interactive lexical network. The nodes in the upper layer represent semantic features. The nodes in the middle layer represent words, and the nodes in the bottom layer represent phonemes. All connections are bidirectional connections, and activation spreads throughout the network without constraints. It is always the most highly activated word that gets selected, and the moment of selection is determined externally by the developing syntactic frame of the utterance, which I find fascinating. When a note is selected, it receives an extra jolt of activation, which triggers its phonological encoding. There is another layer representing phonological features such as voiced and nasal features, which we'll save for another day. In this figure, language-related regions of the left hemisphere are mapped by positron emission topography in a typical patient. Language tasks such as listening to words and generating words elicit activity in Broca's and Wernicke areas. This figure illustrates the general language pathway. Language input from visual or auditory cortex goes first to Wernicke's area, which performs the final stages of language comprehension, and then Wernicke's area connects to Broca's area, and Broca's area is responsible for production of meaningful language. And then the output from Broca's area goes to the motor cortex for control of the voluntary muscles required to speak or write words. This picture illustrates the speech pathway, starting from the primary auditory area, going through Wernicke's to Broca's and to the primary motor cortex, and then down the brainstem to the muscles of the larynx. This illustrates the implicit framework underlying the storage access distinction. The typical adult state is shown on the left. There is a collection of words or concepts and a mechanism for accessing them. A storage deficit is shown in the middle. Some of the words or concepts are missing. An access deficit is shown on the right. The words or concepts are intact, but the access mechanism is broken. According to Brookshire, individuals with aphasia experience word retrieval access deficits, decreased retention and storage capacity for language units, and demonstrate deteriorating performance as the units to be processed becomes longer, more complex, or more uncommon. Paraphasias are the major behavioral consequence of word retrieval difficulties. Two types of paraphasia errors are identified: verbal paraphasia, which is semantic, and literal paraphasia, phonemic. With verbal paraphasia, the entire word is substituted for the intended word. Remember our two-step model? Well, it is a problem with that first step. Remember, the nodes in the upper layer represent semantic features, and the nodes in the middle layer represent words. It is during this word selection process that something goes wrong. So the verbal paraphasia may relate to the target in meaning, like table for chair, or it may relate to the target in sound, like train for tree. And it may relate to the target in both meaning and sound, like snail for snake. With literal paraphasia, we return to our two-step theory model for word retrieval. When a node is selected, it receives an extra jolt of activation, which triggers its phonological encoding in the third layer. Faulty encoding of the phonological representation of the retrieved word gets sent down to Broca's area for articulation. Literal paraphasia is an incorrect production of some of the sounds in the words, like pote for coat or shoosh brush for toothbrush. 50% of target phonemes are present and is restricted to open class vocabulary such as nouns, verbs, adjectives, and adverbs. It's phonotactically well formed as well, meaning for English speakers, they won't begin a word with sound. Neologisms are also at times referred as a type of paraphasia, with 50% of the target phonemes not present. They're considered a made-up or non-existent word. Data derived from some studies suggest that neologisms are a problem in the lexical phonological retrieval. Unintentional circumlocution is talking around the missing word, and there's also intentional circumlocution, which is used as a compensatory strategy. Empty speech is also used, and it's when it's substituting general words with thing or stuff. Therapy needs to focus on activating new neural pathways for words. There was a time when, for these folks with Wernicke's, gesture training was only used as a strategy to compensate decreased communication. There are many types of gestures, but therapy mainly uses three well-established and empirically based gestures: iconic, used to show physical, concrete items; pantomime, used to describe objects and actions in a sequential manner; and emblem, familiar to a given community, like giving the OK sign or the thumbs up. Empirical studies have shown gestural training can facilitate word retrieval in patients with aphasia. They have shown that successful word retrieval can happen more with a gesture than without. Studies show that verbal plus gestural training is effective for both noun and verb retrieval. So what is gesture plus verbal training? It's learning to pair gestures with pictures to facilitate word retrieval, and studies have found that mapping a gesture to a spoken word increased naming for trained words, and generalization of gestures to novel untrained nouns and verbs was possible. So what's next? Communicative impact and benefits have been minimally explored, and there is really no information on whether participants used taught gestures during daily interactions. Research's logical next step is to explore whether gesture and naming can enhance communication. Do gestures have a new role in aphasia therapy? In a study, Cott et al. Explored whether gesture and naming treatment improved performance in conveying messages and narratives to a partner. They used standard and personal items that could be gestured and pictured: food, drink, clothes, transportation, activities, furniture, and personal objects. Gesture-treated items and naming items and untreated items were all used. After training on the words, they used those same words and performed a message assessment and a narrative assessment. They discovered that training a vocabulary of gestures and words increased participants' ability to convey information through messages and narratives. The studies suggest that gesture and naming treatments can benefit interactive communication, and that the gains seen reflect the development of general communication skills rather than the use of trained gestures and words. So, do gestures have a new role in aphasia therapy? Yes, I believe they do. Don't you?